The National Electrical Code, or NEC, is the primary resource for electrical codes and standards in the United States. It includes specifications for wire sizes, types, and applications. You can access the NEC through the National Fire Protection Association, or NFPA, website. Wire manufacturers' websites and datasheets contain detailed information about their products. These include wire specifications, ratings, and application recommendations. Examples of wire manufacturers include Southwire, General Cable, and Belden. Several electrical training and reference books can provide valuable information. Examples include Electrical Wiring Residential by Ray C. Mullen, Ugley's Electrical References, and Lyman's and Cableman's Handbook by Thomas Shoemaker and John S. Abbott. Industry standards organizations also provide relevant information. Underwriters Laboratories or all publishes safety standards for electrical products, including wire. The American National Standards Institute, or ANSI, develops voluntary consensus standards for various industries, including electrical wiring. Wire type comparison charts and tables are available online. For example, Southwire offers a wire type comparison chart on their website. There is also the Electrician Helper app. Now let's discuss some key differences between size 14 American wire gauge, or AUG, type TW and type THHN wire. Firstly, consider the temperature rating. Type TW wire has a temperature rating of 60 degrees Celsius, which is 140 degrees Fahrenheit. Type THHN wire has a temperature rating of 90 degrees Celsius, which is 194 degrees Fahrenheit. Secondly, look at the insulation material. Type TW wire uses thermoplastic insulation. Type THHN wire uses a heat-resistant polymer, specifically cross-linked polyethylene. Thirdly, consider the applications. Type TW wire is suitable for residential and commercial applications with low voltage and temperature requirements. Type THHN wire is suitable for industrial applications, high voltage systems, and locations exposed to extreme temperatures. It's important to note that American wire gauge, or AUG, refers to the wire size. Lower American wire gauge numbers indicate a larger wire diameter and a higher current carrying capacity. When selecting wire for a particular application, consult the NEC manufacturer's specifications and relevant industry standards to ensure you are using the appropriate wire type and size for the intended use. Always prioritize safety and compliance with electrical codes to prevent hazards and ensure reliable performance. Additional details to consider when selecting wire include the ampacity, which is the current carrying capacity of the wire, the voltage drop, which is the reduction in voltage along the length of the wire, and the environmental conditions such as temperature, moisture, and exposure to chemicals. The NEC provides tables that specify the allowable ampacities for different wire types and sizes based on their insulation rating and installation method. For example, NEC Table 310.15b16 provides ampacity ratings for conductors insulated with various materials such as THHN, THW, and XHHW under different conditions. It is important to direct the ampacity of the wire if it is installed in an environment with a high ambient temperature or if multiple conductors are bundled together in a conduit. The NEC provides adjustment factors for these conditions in tables 310.15b2 and 310.15b3. Voltage drop is another important consideration, especially for long wire runs. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. The voltage drop can be calculated using Ohm's law and the wire's resistance per unit length. Wire manufacturers typically provide this information in their data sheets. The environmental conditions can also affect the choice of wire. For example, if the wire is exposed to moisture, a moisture-resistant insulation material such as THW or XHHW should be used. If the wire is exposed to chemicals, a chemical-resistant insulation material should be used. The NEC provides information on the types of insulation materials that are suitable for different environmental conditions. Here's a slightly more detailed look at temperature ratings. The temperature rating of a wire indicates the maximum temperature at which the insulation can operate safely. Exceeding the temperature rating can cause the insulation to degrade, leading to short circuits, fires, and other hazards. It is important to select a wire with a temperature rating that is appropriate for the ambient temperature and the heat generated by the current flowing through the wire. The NEC specifies the maximum allowable conductor temperature for different types of equipment and installations. Considering insulation material plays a critical role in protecting the conductor from damage and preventing electrical shock. Different insulation materials have different properties, such as temperature resistance, moisture resistance, and chemical resistance. Thermoplastic insulation materials, such as polyvinyl chloride or PVC, are commonly used for general-purpose wiring. Cross-linked polyethylene, or XLPE, insulation materials offer high temperature resistance and are often used for high-voltage applications. When talking about application suitability, selecting the appropriate wire type for the application is essential for ensuring safety and reliability. Type TW wire is suitable for general-purpose wiring in dry locations. Type THHN wire is suitable for high-temperature applications and can be used in both wet and dry locations. Other wire types, such as TW and THHN, are suitable for direct burial applications. American wire gauge, or AWG, is a standard system for specifying wire sizes. The AWG number indicates the diameter of the wire, with lower numbers indicating larger diameters. Larger wires have a higher current carrying capacity and can handle more power. The NEC provides tables that specify the allowable ampacities for different wire sizes. Remember, always consult the NEC, manufacturer specifications, and relevant industry standards to ensure you are using the appropriate wire type and size for the intended use. Prioritize safety and compliance with electrical codes to prevent hazards and ensure reliable performance. Additional resources for understanding wire types and differences include electrical engineering textbooks, online forums, and training courses. These resources can provide more in-depth information on the properties of different wire types and their applications. Always seek guidance from a qualified electrician or electrical engineer if you have any questions or concerns about selecting or installing electrical wiring. Let's further elaborate on the NEC role. The NEC is updated every 3 years, so it is important to use the latest edition. The NEC is a comprehensive document that covers all aspects of electrical installations, from wiring methods to equipment grounding. It is essential for anyone involved in electrical work to be familiar with the NEC. Diving deeper into manufacturers' data sheets, these data sheets provide detailed information on the wire's electrical and mechanical properties, such as its resistance, tensile strength, and elongation. They also provide information on the wire's installation requirements, such as the minimum bending radius and the maximum pulling force. Focusing on industry standards, these standards provide guidelines for the design, manufacture, and testing of electrical products. Compliance with these standards ensures that electrical products are safe and reliable. Speaking about wire type comparison charts and tables, these resources provide a convenient way to compare the properties of different wire types. They typically include information on the wire's temperature rating, insulation material, ampacity, and application suitability. In addition to the wire types discussed earlier, there are many other types of wires available, each with its own unique properties and applications. Some common wire types include UF, use, NM, NMC cable. UF wire is underground feeder cable which is designed for direct burial applications. Use wire is underground service entrance cable, which is used to connect the power company's service drop to the customer's meter. NM cable is non-metallic sheath cable, which is commonly used for residential wiring. NMC cable is metal-clad cable, which is used for commercial and industrial wiring. The choice of wire type depends on the specific application and the environmental conditions. Here's a more extensive look at the differences between type TW and type THHN wire. Type TW wire is a thermoplastic insulated wire that is commonly used for general purpose wiring in dry locations. It has a temperature rating of 60 degrees Celsius and is available in sizes ranging from 14 American wire gauge to 2 American wire gauge. Type TW wire is relatively inexpensive and easy to install. Type THHN wire is a thermoplastic high heat resistant nylon coated wire that is commonly used for high temperature applications. It has a temperature rating of 90 degrees Celsius in dry locations and 75 degrees Celsius in wet locations. Type THHN wire is available in sizes ranging from 14 American wire gauge to 2000 kc mil. Type THHN wire is more expensive than Type TW wire, but it offers better performance in high temperature environments. The insulation material of Type TW wire is typically polyvinyl chloride, or PVC. The insulation material of Type THHN wire is typically cross-linked polyethylene or XLPE with a nylon jacket. The nylon jacket provides additional protection against abrasion and chemicals. The applications for Type TW wire include general-purpose wiring in dry locations, such as lighting circuits and receptacle circuits. The applications for Type THHN wire include high-temperature applications, such as wiring for appliances and motors. Type THHN wire can also be used in wet locations, such as underground conduits. When selecting wire for a particular application, it is important to consider the following factors: the ampacity of the wire, which is the maximum current that the wire can carry safely; the voltage drop of the wire, which is the reduction in voltage along the length of the wire; the environmental conditions, such as temperature, moisture, and exposure to chemicals; the cost of the wire. By carefully considering these factors, you can select the appropriate wire type and size for the intended use. Always consult the NEC and other relevant standards to ensure that your wiring is safe and compliant. The NEC specifies the allowable ampacities for different wire types and sizes based on their insulation rating and installation method. The NEC also provides guidelines for calculating voltage drop and for selecting wiring methods for different environmental conditions. It is important to follow these guidelines to ensure that your wiring is safe and reliable. In addition to the resources mentioned earlier, there are many other resources available for learning about wire types and differences. These resources include online forums, training courses, and electrical engineering textbooks. By taking advantage of these resources, you can expand your knowledge of electrical wiring and improve your ability to select and install wiring safely and effectively. Always prioritize safety when working with electricity. Electrical work can be dangerous, and it is important to take precautions to protect yourself from electrical shock. Always disconnect the power before working on electrical circuits. Use insulated tools and equipment. Wear appropriate personal protective equipment such as safety glasses and gloves. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. Electricity is a powerful force, and it is important to respect it. By following these safety precautions, you can protect yourself from electrical shock and ensure that your electrical work is done safely and effectively. Consider also the wire's resistance to corrosion. Some wires are specifically designed to resist corrosion in harsh environments, such as those with high humidity or exposure to chemicals. These wires typically have a special coating or insulation that protects the conductor from corrosion. Furthermore, think about the ease of installation. Some wires are easier to install than others depending on their flexibility, weight, and the type of connectors that are used. For example, solid conductor wires are typically stiffer and more difficult to bend than stranded conductor wires. Also, push-in connectors are generally easier to use than screw-type connectors. Keep in mind the long-term reliability of the wire. The wire should be able to withstand the stresses and strains of its environment without degrading or failing prematurely. Factors that could affect the long-term reliability of the wire include temperature, humidity, vibration, and exposure to chemicals. Selecting a high-quality wire from a reputable manufacturer can help to ensure its long-term reliability. Finally, take into account the overall cost of the wiring project. The cost of the wire is just one factor to consider. Other costs include the cost of connectors, conduit, and labor. It is important to factor in all of these costs when selecting wire to ensure that the project stays within budget. Remember to carefully consider all of these factors when selecting wire for a particular application to ensure that the wiring is safe, reliable, and cost-effective. Always consult with a qualified electrician or electrical engineer if you have any questions or concerns.